We're talking about ARM data instructions. And the ARM data instructions specify, first of all, a condition code, and then they specify a instruction or a data operation, add, subtract, multiply, divide, whatever. And then they specify 3 operands, a destination, a source, both of which are just regular registers, and then the second source can be an immediate instruction, which we just talked about in the last 2 videos, or it can be a shifted regular register. This is how that representation works. Again, the second operand is represented in 12 bits, but in this case, if you specify that you're not using an immediate value, you're using a register value instead, those 12 bits are interpreted differently. They're interpreted in one of 2 ways. Actually, here is the sheet, and there are 3 ways to interpret operand 2. If the I flag is 1, then it's an immediate value, which is an immediate value rotated by twice the alignment, which we just talked about. If the immediate flag is 0, there are 2 possibilities. You're going to take a register and you're going to shift it by an immediate value, or you're going to take a register and shift it by a register value. So in both of these cases, we're shifting. What we shift is specified in this flag here. Flag 4, this bit says whether we're shifting by an immediate value or whether we're shifting by a register value. So let's dig into that. In this case here, we have the second option, which is a register shifted by an immediate amount. Okay? If bit 4 is 0, that means that we are shifting the register by an immediate amount. We have to specify 5 bits for the immediate shift. It's an unsigned number, and it's 5 bits because we have to specify any shift between 0 and 31, because it's a 32-bit number, and we could shift any amount within that 32-bit number. So 5 bits for an immediate shift. Bits 6 and 5 are going to specify the shift direction, and then the last 4 bits are going to be the register that we're actually going to take and shift. So we specify the register that we're going to shift. We specify whether we shift it by an immediate amount or a register amount. In this case, we're shifting it by an immediate amount. We specify the shift direction, and then we specify the shift amount. And that shift amount is a 5-bit immediate value. Then the shift direction, just like everything else in ARM, is a simple case and a complicated case. So we've got 3 simple cases. If it's 0, 0, it's a logical shift left. If it's 0, 1, it's a logical shift right. If it's 1, 0, it's an arithmetic shift right. And if it's 1, 1, it's a rotate right. Oh, sorry, 4 regular cases. Logical shift left, logical shift right, arithmetic shift right, rotate right. And then we've got a 5th case where if we rotate right by 0, we're actually going to rotate right and extend. And this is the idea here is if you want to rotate a bigger number, right, take 2 32-bit numbers and rotate them around, then we have to rotate through the carry bit to the next 32-bit number. And that's what ROR by 0 means. We're actually rotating it right by 1 bit shifted through the carry. Again, simple case, complicated case. So the 2 bits here specify one of these shift possibilities, logical shift left, or 3 different kinds of shift right, logical, arithmetic, and rotate. And then you can also specify a rotate right through the carry for an extended rotate. LSL is logical shift left, LSR is logical shift right, ASR is arithmetic shift right, ROR is rotate right. You don't need a rotate left because you can rotate right by 32 minus that. You don't need an arithmetic shift left because it doesn't make any sense. Arithmetic shift left, arithmetic shift right, you copy the sign bit. That's what makes it an arithmetic shift instead of a logical shift. But if you're shifting to the left, you're going to obfuscate the sign bit anyway. So it doesn't make any sense to arithmetically shift left, so you don't. You either logically shift left, or you logically, arithmetically, or rotate to the right. Those are your options. And here's some more discussion about why you can't shift to the left in these ways. You don't need to shift. You don't need to rotate left because you can rotate right by 32 minus that. And you don't need the arithmetically shift left because it doesn't make any sense. So we'll skip that. Now, you can either shift by an immediate amount or you can shift by a register amount. If you want to shift by a register amount, what you do is in a previous instruction somewhere, you store in the bottom 5 bits the amount that you want to shift by, and then you specify a 1 here in bit 4, and that says don't shift by an immediate amount, shift by a register amount. Okay, so register, and you're going to shift it by a register amount. Again, the shift value or the shift direction is specified in the same way, and then you specify a 4th register, which contains the shift value. So the way that those look, do I have an example of one here? Yeah. Here we go. Okay, so this is an example of adding two numbers together, one of which is shifted. So you're going to add into register 1 whatever's in register 2 plus whatever's in register 3 shifted by whatever's in register 4. This is how shifting is done in ARM. You don't have standalone shift instructions. You have shifting as a component of another instruction. And so if you want to just take and shift a value, you have to do that by adding it to 0 or something, or adding it and not modifying the result in some other way. So this is what it's going to look like for shifting by some register, and then this is what it's going to look like for shifting by some immediate value. Move into R3, and this is the correct way to take a value and just shift it. You're going to move into R3, whatever's currently in R3, logically shifted by 1, right? Or you could do it this way. You could say move instead of add into some register, the current value of the register shifted by some new register. Okay? So you're going to specify the register and then the direction to shift it by and then the amount to shift it by, either in a register or in an immediate value. And those are the ways that you shift, right? There's no dedicated shift instruction. All 16 data processing instructions can use a shift. So that's, again, combining things together, which makes things really interesting, right? Because you can then multiply by 2 and also add at the same time in a single instruction, which is very exciting. Or you can construct independent standalone instructions using move that then builds that shift amount built into it. So that's how shifting works in ARM. And so that's all of the all of the simple data processing instructions. As we'll see, multiplication and a few other things are slightly more complicated. But that's the basic data processing instructions. Each one is conditional. Each one can also be any add, subtract, shift, rotate, etc. Right? Each one can include logical instructions like or exclusive or. Okay, so there are 16 opcodes for the different data instructions. They look like this. Those are the different opcodes for what the instruction will do. There are 16 opcodes for conditions. They look like this. These are the opcodes for the different condition codes. Each can be conditional. Okay, there are 3 operands specified. One is the destination, which is a simple register specified by 4 bits. One is one of the sources, which is a simple register specified by 4 bits. The last operand is 12 bits, which specify either an immediate value in this complicated alignment format, 8 bits of value shifted around a 32-bit number by an even shift amount, or a register shifted by a register amount, or a register shifted by an immediate amount. Those are the options for your second operand. If you don't want to shift, you just leave that out, and the assembler will fill in the shift value by 0. Shift by 0 means not shifting. So essentially, every second operand is shifted, but you can choose to shift it by nothing, and then you're just adding 2 numbers together. So in general, the format looks like this. Again, we talked about this before, but this is just a review. You put the opcode, then you put the condition code if you want it, then you put that you're going to store the condition codes, the result codes in the current program status register, N, Z, V, and C, if you want them. If you leave that S flag off, you don't store N, Z, V, and C, and then they're just whatever they were before. Then you specify a destination register, a source register, and a second source, which is either an immediate value, value shifted by register, value shifted by immediate. And that is the data processing instructions. So you can get the sort of trend of ARM. Simple cases, more complex cases, right? Optimization for simplicity, and then complicated cases can be done more difficult.